In this video, we're going to start fine-tuning using Modal, and we're going to do it quickly, so we can get up and running with Meta's latest edition of models. Using Modal, so these are the contents for the video. I'm going to start off with why I'm using Modal. Firstly, the concept of the self-provisioning runtime. For me, it's just been an easy and intuitive containerization serverless compute experience due to the unification of application and infrastructure code. And so it's been super quick as well, really quick cold start, so that's been great for iteration velocity. And I'm GPU poor. So on their free tier, they've got $30 per month of compute for free, and that's as of 9th of August 2024. And they've got top tier options available, whether that's NVIDIA H100s or A100s with 80 and 40 gigabytes of VRAM. So I'm not an affiliate, but a happy user. And they provided the infrastructure and serverless compute platform to get me up and going for fine-tuning jobs. So it's a situation where I better shout them out for this one, and they've done the heavy lifting with the repo, so creds go out to them. So why fine-tune? Customizability, e.g. teach an LLM or LMM a new language. Controllability, so like instruction following, alignment of your preferences for your user experience. Privacy, so greatly improved privacy with open source models. So many different use cases get opened when you use open source models, and fine-tuning them then allows you to add performance on that. And then we're going to be using low rank adaptation here, where you train adapters which then get merged on top of the base weights. And one benefit of this is it's much less resource intensive, much quicker, and it's non-destructive, so you can avoid catastrophic forgetting. And another benefit is dataset curation. I mean, improving your fine-tuning results from improving your data. Garbage in, garbage out is the classic phrase used here. So a massive part of the future might be things like Gradient's Llama 3 with 4 million token context window at the 8B parameter level, so you can teach a new style within the context window. So if no one's seen this, this is an example where Gradient teach an LLM how to write in the style of Mark Twain, utilizing up to 951k tokens and seeing benefits up to that amount. So that's a hidden benefit that I came across recently and wanted to share here. Alright, so now onto the required setup. So you're going to need Modal's LLM fine-tuning repo, which for Llama 3.1 compatibility, you'll need to update VLLM, PyTorch, and Axolotl base image, and then utilize Llama 3.1, a config file, which I've got an open pull request with all of these updates. However, for compatibility, if you're now cloning the repo, the changes made are one commit behind, so you might just want to change VLLM, PyTorch, Axolotl, and get the config file yourself. Secondly, you'll need a Hugging Face token. This is the one option you'll need minimum. You can give more privileges, of course, but I'm just minimizing unnecessary privileges here. So optional setups, which I'll be using, is weights and biases, but you can also use my MLflow for observability. And then we're also going to be utilizing an Axolotl config file, which has many different options like QLoRa, editing your eval strategy, logging, hyperparameters, and many more. So these are some additional things that you can do for observability and for customizability, controllability, squeezing out more performance. All right, onto the walkthrough now. So now onto the code. So we've got Llama 3.1 8B here. This is really just Llama 3's config file, and literally just plug and played Llama 3.1. Make sure you get access from the gated model that this is, and your access should be granted immediately. With that being said, it's really only one command. It's this command here to be able to run Modal detached. So if your client disconnects, the app will still run. We're running the train.py file, config file to use Llama 3.1, and then the data we're going to be utilizing is a subsample of a SQL QA dataset, which looks like this. It's a JSON line file. So with that being said, let's run that now and show you the performance and how long it takes to just get up and running, having cloned the repo, adding a config file, and sort of editing some environment variables. There's a lot of things that you can do here. So the run is preparing now. It's going to utilize Axolotl to do the heavy lifting. And yeah, it really shouldn't take much time to get up and running. That's the beautiful thing about utilizing this repo from Modal and utilizing their compute platform, is it really just is very quick. So while that's waiting, so now you can see we've got an ephemeral app going. This is still the same run, there'll be a cut, but this is an ephemeral app running on 2 A100s, a train file, and so you can see we've got one container with one input, and this is just running really nicely. Some nice logs here. And so yeah, up and running now. We're about 2 minutes into the train. And so a few minutes in here, and we're actually going through epochs. The loss is going down. And so there's a lot of warnings here. You can play around with the config file to silence these and sort of get around the issues that are causing them. But essentially what I want to show you is that you can really get up and running like within minutes. So about 5 minutes later, and we're now in weights and biases to check the run. And so this is the run that's just finished. You can see metrics for training loss. You can see metrics for the learning rate, how it trended over time, and the epochs and such. So that's here for observability, and that's here to get you going with the weights and biases set in the config file. This is weights and biases with weights and biases watch set to all. So you get these straight out the box, but with the Axolotl config file, you can edit things more. So here we are now. What I'm going to do is I'm going to show you an old run and just show you how to run inference on this as well. This is in the repo, but what I just wanted to show you is you can also get very quickly set up to serve your model and give prompts in this following template here. And so here we go. What I'm going to do is I'm going to paste the prompt that's in the repo. You can use the prompt flag within the command to run inference, and you can also use serverless compute. And you can also deploy it very quickly with 2 commands. Right, so to wrap it all up with a conclusion, we've introduced Modal and all the benefits that come with this platform. We've discussed the benefits of fine-tuning, specifying with LoRa 2, and then we fine-tuned Llama 3.1 in minutes. And next up is supervised fine-tuning for instruction following. As we've just done this on a pre-trained model, the instruction following capabilities of these pre-trained models are not consistent, so we leverage instruct models via supervised fine-tuning. So what you can do is you can either just plug and play Meta's instruct version, or you can create or leverage a supervised fine-tuning dataset. This allows you for more customizability. Your use case may actually require it if the instruct model has unnecessary refusals for your user experience. So it's a situation where you can go in, experiment, and see whether or not instruction fine-tuning is actually necessary for your use case, or you can just plug and play an instruct model. Evaluate, of course, you can use some vibe checks and then some actual rigorous evaluations. To leave you with another tidbit from the AI Engineer World's Fair, this one comes from Maxime Labonne on creating high-quality supervised fine-tuning datasets. This is a recipe that I intend in leveraging for the future, and hopefully you do too. Alright, so thank you very much for listening, and any feedback will be welcome in the comments.